My name is Dave Strain. I'm president of APS. It's a systems development company that specializes in improving the energy performance on HVAC systems. In a lot of buildings that we've done, we've reduced the energy consumption by over 50% by simply injecting common sense logic into those systems. This particular video focuses in on a type of heating cooling arrangement found in many offices and school buildings, where there is a cooling function called VAV Box in conjunction with a perimeter heating valve. The thermostat controls both, such that as the room starts to warm up, the thermostat drives the heating shut completely. And if the room continues to warm up a little bit more, the VAV box starts to bring in more than the minimum ventilation quantity to provide cooling function to suit what the heat gains are in that room. This page illustrates a VAV variable air volume box integrated with a perimeter heating valve, a common configuration in modern HVAC systems. The room thermostat modulates both the perimeter heating valve and the VAV box through the airflow controller for cooling and ventilation. Because this VAV box is equipped with an airflow controller, a standard practice in most installations, the thermostat sends a control signal requesting a specific flow rate. That airflow rate can vary across the defined range. From minimum airflow setting, often approximately 25% of the box's designed capacity, to maximum airflow as specified by the HVAC design engineer for the building. Operating condition for this example, the thermostat set point is 21 degrees Celsius. The actual room temperature is 21 degrees Celsius. The thermal balance is only requiring partial cooling for the gains and losses of heat. The perimeter heat is off. The VAV box airflow operating approximately 50% of its maximum design capacity to provide cooling. In this condition, no heating is required. The space is maintained by moderate cooling airflow only. The ventilation function. The minimum airflow setting for the VAV box is not arbitrary. It is specifically configured to meet the minimum ventilation and air change requirements for the space, assuring that it will meet indoor air quality compliance with proper fresh air delivery and code-required ventilation standards, even when cooling demands are low. This configuration demonstrates how a VAV box and a perimeter heating valve system balances comfort, ventilation requirements, and energy through combination of modulation of airflow and heat. This next slide presents a situation where we have a defective control valve. So even though the valve is driven closed by pressure, the seat is defective and water is leaking by, in which case it's putting heat into the room that the room doesn't need. And what happens with that is the thermostat then sends a signal on further to the VAV box and increases the quantity of cooling going into the room to compensate for the heat that should not have been going into the room to begin with. This page illustrates a condition where a perimeter heating valve in a VAV box can waste a significant amount of energy, often without causing enough temperature change in the space for occupants to notice or complain. In this scenario, the VAV box is modulating correctly, exactly as it is designed to. However, the heating valve, despite having sufficient control pressure to remain closed, as shown in the first example, it is passing heat. This heat leakage is typically caused by mechanical wear and tear on the seat or disc in the valve. The disc functions much like a washer in a household faucet. When it degrades, leakage occurs even when the valve is supposedly closed. From a controls perspective, the thermostat believes that the heat is shut off because the actuator pressure is at 15 psig. In reality, only 6 psig is required to fully close the valve, so the control system continues sending a cooling signal, assuming there is no heat being added. At the same time, the same 15 psig signal is sent to the airflow controller, instructing the VAV box to provide maximum cooling to the space. In effect, the system is fighting itself. Unwanted heat from the leaking heating valve is being offset by increasing cooling airflow. In the worst case scenario, the VAV box can increase the airflow up to 100% of its capacity, which will be more than enough cooling to compensate for the heat leakage. As a result, the room temperature remains relatively stable, making the system mask the failure. In this specific case, space temperature increased only by 1 degree, far too small for a change to trigger occupant complaints, allowing the energy waste and equipment failure to remain hidden and undetected. There are two major threats to the well-being of the current children we have in society. One is climate change, and the other is the depletion of fossil fuels. On our website, apscontrols.org, we have an article, Fighting Climate Worry. And in that particular article, there's a link to the BBC study on the psychological impact of climate change on children. And also there's a link to the Stanford University study on the upcoming depletion of fossil fuels. We need a lot of support from the public to get the government to move in the correct direction. We're not asking for money from anybody, but we are asking for your political support. Could you please contact your member of parliament, both federally and provincially, and ask that they have their experts look at these science that we're presenting. And we have a lot of HVAC reports on our website, which you can see. And also we have a patent that's internationally patented, and it can help significantly with respect to reducing climate change. Thank you very much for your efforts in watching this video.